Very good morning, class. In the previous video, I have completed the combination of pulleys, and that was the block and tackle system. We saw how we can calculate the mechanical advantage as well as the velocity ratio and the efficiency of that system. For the quick revision, the mechanical advantage of that system basically is equals to the number of pulleys, right? Similarly, the velocity ratio was also equal to the number of pulleys, and in this case the mechanical advantage as well as the velocity ratio is equal. Hence the efficiency of the block and tackle system case will be 100%. So today I will discuss some very important numerical from this portion. So let's continue the numericals. So numerical 1, what is the condition? Condition, we have a fixed pulley like this, and a woman is taking the water from the well with the help of a fixed pulley. She is applying the total force of 70 Newton to overcome the mass, which is 6 kg, right? This 6 kg include the mass of water and the bucket, right? So in this case we have to find the mechanical advantage of the pulley, right? What is the mechanical advantage? Mechanical advantage is nothing but it equals to load upon effort, right? What will be load here? Load will be equals to mg, right? Here L will be equals to mg, and effort will be equals to force she is applying, right? So MA will be M is 6, and obviously G, it's given in the question, it is 10 meter per second square, and the effort or force she has applied is 70 Newton. So from here you will get so this will be the mechanical advantage in this case. Let's discuss the next numerical. So here's the numerical third. It says we have one single fixed pulley and another single movable pulley, and both the pulleys are used to overlift the load of 50 kgf, right? We have to find the ratio of the effort applied in these cases. So let's say here I am applied the load effort E1, and here I am applying the effort E2. In the both cases L is same. So if you remember, what was the mechanical advantage in case of the single fixed pulley? The mechanical advantage is, let's say I am saying it is MA1, it is 1, right? So 1 equals to, what is the formula? Load upon effort. So load upon effort, that is E1. So basically E1 will be equals to L, or simply 50 kgf. So in order to lift the load of 50 kgf, we have to apply the same amount of effort on the other side. Now in the case of single movable pulley, the mechanical advantage in this case, let's say it is MA2, if you remember that was 2, right? That means MA2, so 2 equals to load upon effort. So load upon effort, let it is E2, right? So E2 will be L by 2. So E1 is L and E2 is L by 2. We have to find the ratio. So E1 upon E2. E1 is L and E2 is L by 2. So that will be 2, right? Or simply E1 is to E2 is equals to 2. So that means we have to apply twice effort in the case of single fixed pulley as compared to the single movable pulley. That means we can overlift this load of 50 kgf by just applying the effort of 25 kgf. So basically effort is half. But in this case, we have to apply the same amount of effort, that is 50 kgf, to overcome the load of 50 kgf, right? Let's see the next numerical. So in question number 4, we have 3 pulleys and they are connected by a block and tackle system. So in 3, I told you in block and tackle system, the upper block always have either equal amount of pulleys or one more pulley in comparison with the lower block of pulley. So if we have total 3 pulleys, so obviously the only one condition is possible, that in upper block we have 2 pulleys and in lower block we have 1 pulley. The upper block pulleys are always fixed and the lower block pulley are always movable, right? So you can see that the upper block pulley's axle is connected to a string with the help of a rigid body, and the next case, the movable pulley, the load is connected to the movable pulley, right? Let's first see how the string will be connected in the system. So you remember I told you start the string from the upper block. So let's say here we are applying the force and it will go like this, right? And the second pulley, and finally it will connect here. Okay, tension and effort will be here. We are applying effort in downward direction, that will be tension here, tension T is here, tension T here, and tension T is here. Okay, fine. Now you can see that we have to find the mechanical advantage and the velocity ratio in this case. We already have the load and the effort. It's quite easy to find these terms. The mechanical advantage will be equals to what? Load upon effort. So load is 75 kgf upon effort is 25 kgf. So obviously the mechanical advantage is 3. Now what will be the velocity ratio, right? So velocity ratio, to find the velocity ratio, if you remember, that was distance traveled by effort to distance traveled by load, right? So now remember I told you if this load is comes upward d times, then effort comes down with n into d times, right? So the effort will cover distance 3 into d while load into d, and that will be 3, right? So VR will be 3 as well. Now we are left with the efficiency. So what is efficiency? Efficiency is mechanical advantage upon velocity ratio into 100. So 3 by 3 into 100, that will be 100%. 3 upon 3 into 100. So efficiency will be 100%. Okay. So say this question is quite easy because we already have the value of load and effort. So it's quite easy to find the mechanical advantage and the velocity ratio. Let's see the another numerical. Numerical number 5. In this question we have says the total number of pulleys in the system is 5. The effort applied is 1000 Newton to overcome the load of 4500 Newton, right? So we have to find out the mechanical advantage and velocity ratio and the efficiency. Now you will say that I told you if you want to find the mechanical advantage, just check out the number of pulleys, right? So if we have 5 pulleys, the MA will be 5 as well as we are also 5, so efficiency will be 100%. Now remember I also told you that this is a theoretical case, this is an identical case, because we have assumed in the identical case that there is no friction between the axle and the pulley, right? And the masses of pulleys are negligible. If these conditions are applied, then only the mechanical advantage will be equals to the number of pulleys. But in practical case, you know that it is not possible. there is some friction always present between the axle and the pulley, and obviously no particle can be massless. If the particle is massless, then it is not the particle, it is an energy, right? So pulley can't be massless, it must have some mass, right? So we how do we find the mechanical advantage? Simple, go through the general formula, right? So what is the general formula for mechanical advantage? That is nothing but load upon effort, right? So that will be, load is 4500 and the effort is 1000, right? So the mechanical advantage will be 4.5, right? Now velocity ratio. Velocity ratio, I told you, velocity ratio depends upon the distance traveled by load and the distance traveled by the effort, right? These things, the distance traveled by the effort or the load, is nothing to do with the mass of the string, mass of the pulleys, or the friction present between the axle of pulley and the pulleys, right? So it is always equal to the number of pulleys. So what will be the VR? It will be 5 into D upon D. Why it's 5 into D? I told you. The distance traveled by the effort is always n times into D, right? What is n here? N is the number of pulleys upon this distance traveled by load, so that will be 5. Velocity ratio. Now efficiency eta. Okay, this was the first part, this was the second part, and this is the third part. Efficiency was mechanical advantage upon velocity ratio into 100, right? So when you solve it, mechanical advantage is what? It is 4.5, VR is 5 into 100. So when you solve it, you'll get 90%. So this is your fifth numerical, right? Now let's see the next numerical. Let's do the question number 10. In this case, it says that the velocity ratio of the system of pulleys is basically 3. So it means the number of pulley is 3. We have to also make the diagram of the system. So let's make velocity ratio is 3. That means number of pulleys is 3. It means in the upper block there will be 2 pulleys, and in the lower block we have 1 pulley, right? So let's make it. We have rigid support, right, and 2 pulleys. They will be in the upper block and they are fixed. So you can see here I have fixed these pulleys, and the lower block will have 1 more pulley. So this is the third pulley. Okay, now let's find the how is the string is connected to the pulleys. So I told you always start with the upper pulley. So this is the effort applying. We are applying here effort E. So this string will come like this. Okay, it will go to the second pulley. There will be hook, and this will be connected to the hook like this, right? And load will be connected here. Tensions, E supported by tension T, and this load is supported by 3 tensions, 1 here T, 1 here T, and 1 here T, right? So that is why the load is equal to 3T and the effort is only equals to T. Now the diagram has been completed. If the efficiency is 60%, we have to find the value of load that this effort can be pick, right? And VR is 3. So we know the relation between the mechanical advantage, velocity ratio, and the efficiency. So first calculate the MA of the system. What will be MA? So MA will be eta into VR, right? So MA efficiency is 60%. So 60 upon 100, right? VR is 3. So that's your mechanical advantage. I'm not calculating further because we can directly find out the value of load from here. Now what will be the value of load, right? We have to calculate the value of load. So MA is equals to load upon effort. So load will be M into A into effort, right? So MA is this, it is 60 by 100 into 3, and what is the value of effort? It is 200 kgf. So it has been cancelled. So 2 into 3 is 6, 6 into 60 will be 360, right? So load will be 360 kgf. So this is the value of load. In the second part, we have to calculate the distance travelled by load if the distance travelled by effort is 60 centimeter, right? So now we have to calculate the distance travelled by the load, right? We have the distance travelled by the effort as well as the VR. So what is the VR? VR is nothing but dE upon dL. So simply dL will be dE upon VR. So what is dE? dE is 60 centimeter upon 3, that will be 20 centimeter. So this will be the value of the distance travelled by load. So I hope you understand how to calculate the mechanical advantages and velocity ratio or efficiency in the case of block and tackle system. So I have covered so many numericals from this chapter. If you have any doubt, you can reach me out and we'll start the next chapter in the next video. Till then, thank you so much.